Peace and prosperity. Today we will discuss firearm disassembly and blueprint interpretation. We're going to execute a controlled partial disassembly of my micro AK47 platform chambered in 7.62 by 39 millimeter, whilst demonstrating tactical precision and tool utilization, and finally pivoting to a technical blueprint analysis. Before we get this business handled, let's do a safety check. I will grab the AK47 platform, remove the magazine. Magazine is empty. Charging handle to the rear. Visually and physically inspecting the chamber, the bolt face, and the magazine well. It's verified that no live cartridges are in my workspace. Professional gunsmiths execute disassemblies with calculated order operations and a little razzle-dazzle of finesse. First, we remove the top cover and the recoil spring assembly, freeing up the bolt carrier group. Go ahead and get that recoil spring out of there. Next, we get the buffer block. The safest way to remove the bolt carrier group is to ensure that the hammer is cocked. Now that we've removed the bolt carrier group, from here, I'm going to use my specialized hand tools to remove the pistol grip and extract the fire control group to analyze its mechanical configuration. Removing the pistol grip requires access to the structural frame components. For this task, proper tool selection is paramount. But before I disassemble my micro AK47 platform, I'm going to go ahead and adjust my camera angle so y'all have a better view of what's going to happen today. As I stated, proper tool selection is paramount. I will be utilizing hollow ground screwdrivers to handle this operation. These bits fill the entire width and depth of the slotted head screw. Standard commercial screwdrivers feature a tapered wedge design which easily slip under torque and can ruin the finish or strip the screw head. This torque design ensures 100% surface engagement, eliminating the lateral slip and shielding the firearm from damage. Parts organization is mandatory. This is a habit to adopt. By segregating our fasteners into a designated area, we can mitigate the risk of losing small components amidst constant shop movement and noisy environments. This also ensures we have an efficient reassembly cycle. Now that we're going ahead and removing the pistol grip, we want to keep all the components together in a compiled area. So I'm going to set it to the side and continue the operations as planned. Next, let's address the fire control group pins. These pins are held under constant spring pressure. We must have proper finesse when working with tension. Attempting to force these components can cause the hammer spring to slip and almost cause an extreme injury to an individual when operating with this weapon system. To extract these pins, I'm using a short, heavily tapered starter punch paired with a dual head brass and nylon mallet. First, I'll remove the safety selector to ensure that there's not going to intrude in any operation that I have going on today. The next order of operation requires releasing the tension off the hammer and the trigger group. I'll be deploying and utilizing my professional tactical armorer's and gunsmith tool that has a brass pick scraper that I can lift the springs with very easily. After gaining control of the springs on the left and the right side, I utilize a rubber band and tie it together so that way they stay together as one system. As you can see, it moves freely about together in one sewing, so that way it doesn't push back with the springs and doesn't launch forward upon removal. Now that the hammer is free of tension and can move freely, I'm going to go ahead and remove the hammer and the trigger pin utilizing this armorer's tool and the pin punch so that way it comes straight out. Utilizing a standard steel pin punch with a long straight shank, hand pressure can push the punch straight through to fully displace the trigger and the hammer pin. Then I will position the nylon face of the mallet over the starter punch. The nylon face ensures that any accidental overstrike will not damage the receiver's finishes. After a few good subtle strikes, the trigger pin comes right out and gives you the trigger. Now we can move forward in taking out the hammer pin, which requires us a little more finesse. And utilizing that finesse gives us the opportunity and maneuverability so that we can use this pick. So we can go ahead and remove the hammer and trigger retaining pin as such. There's that said pin. Now we take the steel punch, set her there, right on out. Now these rivets are very important to watch for because this is the same side that the retaining pin needs to enter, so that way it maintains its structure in the firearm. Now here, taking the hammer out, you just do a nice little twist and pull. And now this is why we have the rubber band in place. so this function doesn't fly all over the place. Now I'm gonna go ahead and readjust my workbench and recenter the camera so we can discuss the blueprint analysis. Now with a successful disassembly, we're gonna pivot from physical manipulation to technical blueprint interpretation. Your gunsmith should understand how physical tolerances dictate the mechanical safety and longevity of your weapon system. Let's analyze a technical blueprint drawing. We're gonna overview 3 critical measurements critical to the fit, function, and structural safety of this AK47 platform. First dimension is the gas port diameter upon the barrel assembly. On the blueprint, the dimension reads exactly 135 thousand inch. This dimension has massive functional significance for this system. The micro AK47 incorporates a significantly shortened barrel compared to the standard rifle length. The dwell time, the duration the bullet spends in the barrel after passing the gas port, is drastically compressed. If this hole diameter falls below specification, insufficient gas volume will redirect into the gas block, leading to short cycling and failure to extract or eject. Conversely, if it exceeds the upper tolerance limits, overgassing will deteriorate parts and inflict severe battering on the rear trunnion of the buffer block. The second measurement focuses on the barrel shank outer diameter where it interfaces with the front trunnion bore. The blueprint indicates a normal reading of 866 thou of an inch, carrying an incredibly tight fit tolerance. This dimension directly dictates head spacing and structural integrity under peak chamber pressures. During the disassembly, I noted how the barrel is securely pinned to the trunnion block. If this diameter is under specification, the press fit will fail, causing the barrel to shift forward under extreme pressures. This creates excessive head space and an unsupported case head and a catastrophic risk of explosion receiver failure during fire. The third dimension is the metal sheet receiver wall thickness, marked with a 39 thousand inch. This measurement connects directly to the practical work we just completed when extracting the fire control group. The thickness of this steel plate governs the lateral support and alignment of our trigger and hammer pins. If the receiver wall is too thin or out of tolerance, the pin holes will deform under continuous recoil forces. That kind of deformation alters the sear engagement angles between the trigger and the hammer, potentially causing a dangerous mechanical failure, such as a failure to catch the sear or an unattended hammer release. You don't want that to happen on the firing range. In conclusion, regarding tool technique utilization, this reinforces that the easiest way to complete a task correctly is to do it right the first time by selecting the exact tool engineered for the job. Mastering the subtle mechanics of proper bit fitting and using nylon faces completely transform how we handle high-value assets. Managing spring loads under tension demands a deliberate deceleration of movement and disciplined parts isolation to maintain safe control of the workspace. Utilizing blueprints bridges the gap between abstract engineering theory and practical workbench execution. A blueprint is more than a reference guide. It's a binding legal contract governing the physical limits of every single weapon system. Moving forward, conducting safety evaluations, executing precise parts fitting, and enforcing unyielding quality control standards across the technical professional portfolio will ensure any gunsmith can maintain a consistent flow of growth and development in the firearms community. Thank you all for your time and attention. Godspeed.